we're going to talk about the backpropagation algorithm, which is the algorithm that tries to solve that problem. Before we do that, we need to briefly refresh on the derivatives, because there's going to be a lot of derivatives in the next couple of slides. So if you got a function, there are several ways to think about the derivative of a function, right? The first, the one that sort of immediately comes to mind is the slope, right? So that tells you how quickly the function is changing around a particular point. The definition that will be a lot more useful to us is different. So another way to think about the derivative of f of x at the point x is an indication of whether the function will increase or decrease if we increase x. Right? So for example, here at x1, the derivative is positive. So if we make x1 bigger, the function is actually going to grow. At x2, the derivative is negative. So if we make x1 bigger, closer to 0, the function is going to decrease. Okay? The third way to interpret the derivative is in relation to the optimum. So suppose that that function f is an error function and we're trying to minimize it in some way. What the derivative tells us is whether our current value of x is higher or lower than where it should be. So we want to be at x star. If we're at x1, the derivative is positive, we know that x1 is bigger than it should be. It should go the other way. If we're at x2, we know we want to make it x2 bigger to get closer to x star because the derivative is negative. Okay. So that's the intuition that'll come useful. Now, some basic rules. Chain rule, right? If you've got a derivative with respect to x of f of g of x, it's just the derivative of x with respect to g and the derivative of g with respect to x. So the intuition is, if f grows a certain number of times faster than g, and g grows, say, twice as fast as x, then you know how quickly f grows as a function of x. So that's the chain rule, and that's the basic thing that we'll need for the algorithm on the next slide. Derivative of the sum is just the sum of the derivatives, except if the derivative is with a parameter that only affects one element of the sum. In that case, the whole sum collapses, and we just look at one element in the sum. So if we're differentiating with respect to xk, then all the elements that weren't all the i's that were not k get cancelled out, and we're only left with the element that corresponds to k. The sigmoid has a particularly funny-looking derivative. So the derivative of the sigmoid is just the sigmoid times 1 minus the sigmoid. And by chain rule, if we want to differentiate a sigmoid of some function, it's sigmoid times 1 minus the sigmoid times the derivative of the function inside the sigmoid, right? That's just from the chain rule.